Okay.
All right.
It is now 2:19, and I want to welcome everyone to this panel, which is on agnostic 5G and do we need, I can go to the exact title here, and the exact title is Agnostic G's Bursting Beyond. Is that right, Muriel? You came up with the title?
Oh, yeah, why not?
Why not? So we're going to talk about future wireless with some wonderful experts on and how we work beyond layers and G's and all those things into the future. And I'm really looking forward to this. But first, I want to welcome you all to the panel. This is sponsored by NETS Virtual Organization. NETS VO is a virtual organization for networking and technology systems researcher, and this is sponsored by NSF. Thank you, NSF. So we have some rules of the road, and the rules of the road are: please mute yourself during the panel presentation, ask questions in the chat. We may not answer your particular question, but we will try and incorporate similar questions into one. We may call on you to ask the question directly, in which case, please unmute yourself. And there was a request, which I think is a great request from one of the panelists, to, if you could, please put your affiliation next to your name so that folks know where you're from. So that's kind of cool. And this meeting will be recorded and archived on our YouTube channel. You should check out our YouTube channel, netsvo.org. And then final, let's see, introductions. I am Katie Wilson. I and Abby Aguirre of Santa Clara University are your moderators. This presentation is part of the Sally Floyd channel, webinars in honor of the pioneering telecommunications researcher, Sally Floyd. And now on to the panel. So as we have another stellar panel today, and I'm very excited that we have Misha Dohler from Ericsson, Muriel Maydard from MIT, Urvashi Mitra from USC, and Ravi Sinha from Reliance. Is it Geo or Joe?
It's Geo.
Geo. Okay. All right. I was trying to do a diphthong there, or whatever it's called. So these folks are well known and need no introduction because you know who they are. But what I'm going to do is I'm going to call on each one of them in alphabetical order just to give an opening statement. So first up is Misha Dohler. So take it away, Misha.
Thank you, Katie. Hello, everybody. So for me, it is a bit of a deja vu moment, really, because when I joined King's College London about, 10 years ago, I had a keynote about the future of telecoms. Of course, back then we had 4G and we were just about to do our baby steps on 5G. And I argued that beyond 5G, we should have no G anymore. And here we are talking about 6G. So therefore, I think it's a good moment now to reflect if we should or should not have a 7G or whatever comes beyond that. So I was always fascinated by innovation and acceleration of innovation. So that has always fascinated me. And I was of a really stern belief that, the G's were holding us back in, shortening that time to market cycle, which we have observed between the generations. So it always takes us about 10 years to get from one G to the other. And no matter what magic we throw at telecoms, we always seem to be within these 8 to 10 years. So now we have a fully softwareized system. You would think, hey, it should now take maybe a week to build the next generation or the equivalent thereof. But yet again, it took us almost 10 years to get 5G really fully up and running. So I learned in London a few really valuable lessons. And one lesson is really I started to learn the difference between technology and the finance, which actually is underpinning all that technology. So if you think that the likes of Vodafone or Verizon are paying out of their own pocket to essentially deploy mobile networks, you're wrong. Actually, there are big investment houses who are supporting these type of deployments. So that is borrowed money, which is being paid back. And that is very important to understand because these investment houses understand really well what happens with between 3G and 4G, 4G, 5G, 5G, and 6G. If the likes of Vodafone or whatever, a large telco, would go to these investment houses and say, every 4 weeks there's a new feature coming, that wouldn't be very helpful in actually getting the finances approved to get the telco systems rolled out. So therefore, the generations have actually been very helpful from a financial point of view, because they've galvanized a very important ecosystem, which was instrumental in getting this out. From a tech point of view, we are actually engineers. I'm speaking we as engineers. We're not working in generations, right? So we're working in releases, and the releases, there are often quite a few releases between those generations, and therefore, we don't have that problem. We've broken down that innovation problem into much smaller steps, and I think that's the right way to go. So, in other words, when it comes to discussion of Gs, I think from an engineering point of view, we're going in releases, so nobody's really talking about generations there. We're going in smaller steps. We can accelerate those steps. Now, I'll come to that in a moment. But in general, we as engineers, we don't talk about generations. We only talk about generations when it comes to finance, when it comes to marketing, right? So again, it's quite a powerful tool to convince people, that something new is on the block. Now, let me just finish off with the acceleration of the technologies, right? So the big question to me was always, how can we make it faster? So I realized that getting rid of the notion of Gs will not help us in getting faster, right? So we will not, if we were just to drop now that whole notion of Gs going from 6G to 7G, 5G to 6G, 6G to 7G, it would still take about 10 years. So some other magic is needed. And I started to work on that when I was in London at King's College, and I called it self-synthesizing networks. And that is really that notion of using AI to help us design networks. And it's very different to the self-organizing networks, where you would use AI to configure networks which have been designed by humans. So what I'm really meaning is use AI to actually build networks, build architectures, build protocols, build your capabilities, and then use another set of AI to configure that. And it was a pipe dream in 2018 is becoming reality, actually. So recently I attended a keynote by NVIDIA. They're using AI not only to configure their hardware, but also to design their hardware. And apparently AI comes up with very quirky designs, which no human ever would have come up with, but which turns out to be optimum from a performance point of view. So I think we are now going into an era where AI will help us to design things. So not only configure things, but design things. And then I think we need to tackle a very important issue around that AI envelope, and that is, what's the role of standards? And I have no answer to that, and maybe we can discuss that today with my esteemed colleagues here on that discussion on the panel. But I'm keen to understand what's the role, what's the future of standards if more and more of the developments will be done by artificial intelligence. I'm gonna leave it at that, and hopefully we have enough meat to open up a discussion further on. Thank you so much, and over to the next speaker,
who is Muriel. Let's take it away, Muriel.
Thank you very much, Katie, and thank you, Misha, for that really, really fantastic setting up of the different points. And I think the question of whether there should be more Gs or not is also related also to what are the Gs, because they're changing. If you look at 5G, it really has in effect a much wider remit, with some verticals which were probably not really part of 4G in the first place. So I think there's also an evolution and sort of a blending of what we would have considered to be, let's say, traditional let's say telephony for the want of for want of a better word, with other aspects such as specialist networks for automation, for robotics, etc. At the same time, we of course are seeing this growing synthesis, syncretism, if you will, among communications and the services that the communications are allowing. And so, the separation between the network and the services, and of course, 5G very much exemplifies that because it's really a service-centered construct. That aspect also means that the whole notion of what a generation is providing is really changing. In the end, you've talked about AI, Misha. Of course, a lot of what the traffic that is being carried is actually no longer for doing what we're doing, communicating, even if it's in a fairly rich medium like video, but increasingly is to carry data, which is feeding AI applications or recommender systems now. But as we go down the road, not just to provide suggestions for ads, but increasingly to provide services and also crucial, really services that we would consider to become in effect utilities. And so I think that what's interesting there is to talk about, what are the G's becoming? And at some point, do they become, in effect, so encompassing? Does their remit grow so much that they change? And that they may be no longer G's in the way that we envisioned them before, but they're now evolutions of, all aspects of computation and communications really looked at in an integrated fashion. So to me, the thing about the end of G's and the question mark is that because are the G's still G's? Are we moving again to something which is going to be different? I think that for us as researchers, as engineers, this is very much along the lines of trying to see, and we see that increasingly in our fields, to what extent communications is integral to other aspects.
Thank you, Muriel. And now on to Ubli.
Great, thank you. So Katie, I'm going to share screen. Hopefully this will work. I was joking earlier that I actually don't know how to give any kind of talk without slides, so bear with me. So I'm going to echo what we've heard already from Misha and Muriel, and maybe my interpretation of it is that we're going from discrete G's to analog G's in the sense that there are incremental changes as we move forward. So I suspect we're going to be talking a lot about AI and machine learning today. I wanted to put out my personal spin, which is this notion of model-based machine learning. One of the advantages that we have for those of us who are working in wireless communications is that there are a lot of models that we've been developing over the years that have worked very effectively. And one of the challenges that we have now is trying to figure out how to bring all of this structural knowledge that we have been developing over the past multiple decades and integrate it in an intelligent fashion with all of this machine learning and AI, because to disregard our accumulated experience would be a mistake, I think. Having said this, I don't think it's actually trivial for us to do this. And I know there are a number of groups, including some of the colleagues that are with me here, that have been, persistently on these ideas over the past few years. And we're finding that it's not as easy as just throwing in another constraint in your objective function. Another idea that I wanted to throw out is that, with all of this machine learning and AI, as well as new technologies like millimeter wave, we should potentially rethink what our classical OSI stack is and recognize that we now have the capability of introducing a so-called learning stack, which might be an application itself or in service of an application, as well as the ability to do much more fine-grained sensing. So trying to figure out where we are, who we are, all of this stuff, imaging, et cetera, our capabilities have increased tremendously. And so this also needs to be integrated into a holistic description or thinking of the entire network. I've been hearing a lot about co-design, and typically when people discuss co-design, they think of software and hardware co-design. I'd like to put forth that we need to introduce algorithms into this mix and understand how we should be doing all of this co-design together. I think of algorithms as not just being software, but beyond software, if you will. So this is something that I would like to see. Misha was talking about, these self-organizing networks and the notion of design. I'd like us to also start designing self-fixing or correcting networks, in the sense that as we make these networks larger and more complex, this is going to introduce a lot of fragility. So we need to be able to self-heal. And as a methodology by which we might consider doing this is an old idea, actually, from statistics, called counterfactual reasoning, where we try to introduce into our network a series of what if questions, maybe even do particular measurements or changes within the networks to understand where the fragility is while it's behaving in its normal fashion, so that we're more prepared for when the unexpected occurs. So can we think about how to design interventions and experimentation during the actual running of the network so that we will be more resilient to anything that might happen in the future? So this is essentially the set of ideas that I wanted to put forward for us to think about. And I hope some of them are a little controversial so that we can have an active discussion. Thank you so much.
Awesome. And last but not least, we have Ravi.
Sure. Hi, everyone. Greetings from Reliance Jio. First introduction, I'm Ravi Sinha. At present, I'm wearing multiple hats for this particular panel discussion. For the last, I'll say 7-8 years, working very closely with Small Cell Forum. They're the de facto promoter of small cell ecosystems in the world, based in London. And I have become the chairman of emerging technology group, at present dealing all up to 5G, anything and everything related to a small cell ecosystem. But recently, a Small Cell Forum has also announced a new initiative called 5G Enterprise Private Network Blueprint. So I'm also chairing that initiative. It's a huge one for the industry, and I'm hopeful that within a year time frame, we will be able to produce something very positive and productive for the industry. Second, I also chair another open source initiative called Enterprise Neurosystems. It is mainly related to federated artificial intelligence consumption. I'm the chair for the telco vertical. So a lot is also happening, which is a kind of good segue to what we are going to discuss. And as you know, that ORAN is the largest de facto SDO platform for product promotions as well as the packaging of it. So I'm also an integral part of it. And a lot is happening related to 6G over there too, or going to happen with time. I have very patiently heard from Muriel, Misha, as well as Urbashi. And they talked a lot about, or in brief, they talked about self-healing or model-based machine learning, and then hardware co-development algorithms with the software and all. They all are great points. But before I jump, I would also like to introduce my company. I work for Reliance Jio. They're the largest, you can say, MNO or the mobile operators in India at present, and number 2 in the world. So we have close to 450 million customers at present, and growing further. In India, you know that 5G spectrum is supposed to be auctioned somewhere in May. So I'm hopeful that at the end of the year, we'll have 5G network ready to go in India. And we are very positive, being Jio, to be a disruptor as well as kind of bringing a great experience, a digital experience for India. So I think I will now move on to some of the very important things what Muriel as well as Ubasi and Misha said. First of all, I think when we talk about artificial intelligence and machine learning, if you see the amount of work ORAN has done, they have done a phenomenal job, especially related to the AI consumptions and all. There was a huge gap. The standardization was there, but definitely the slicing and split of distributed architecture was a challenge where ORAN has taken the lead, and they have done a great job splitting phi, as well as in future, I'm sure that there'll be multiple splits further based on the different use cases. Or there may be aggregation, just like split zero we are talking about. Self-healing is I'm seeing deployed in India itself for the last, I would say, 6-7 years. But yes, I think the definition of self-healing is changing. Earlier, you'll be surprised to know that when self-healing came, it was just to get the FCAPs, get the analysis done, and later on we'll figure it out how to manually tweak, because the people who are managing the network, they're very scared. If they dynamically change it, what will happen? Because machine learning and real-time learning and correction and auto healing, that thing was not exactly deployed. Even with 5G, what I'm seeing is that SON, all the SON concepts are slowly moving from a standard, you can say, a based or a hardware software coupled kind of architecture to a software decoupled with hardware going to a cloud asset arrangement. But then again, it is going all up to the regional data center or maximum up to a metro edge, not below that. No one is really kind of able to bring it down. But if you think about 6G, what we are going to talk, it's all about native cognitiveness. We're talking about native AI going all up to the telco edge, which is the lowest layer you can go to. I think the challenges are that how you'll be doing, what will be the cost, what will be the edge framework, how we are going to do it. All those things we are going to discuss. But then again, as I was telling that Oren has done a great job, especially defining the management layers and interfaces going from XApp to RApp to how the federated artificial intelligence will consume it, at least up to some extent they have done. But what I can see that the missing piece is from the core side, missing piece is from the transport side. How? Because unless you take care of all three of them, you will not be able to do auto drive connectivity, a complete smooth cognitive transition going to a pure 100% management as well as cognitiveness to the connectivity layer. So those are the challenges, and I'm sure that NWDAF and a couple of other things. 3GPP on the other side, I'm seeing that they're doing a lot of heavy lifting, and I'm sure that there are a lot of studies you're going to see in coming 1 or 2 years, and especially oversee a lot of things. What you're saying, we'll talk about it. Like there are some pieces already existing, and they're going even forward. I'm sure that Misa is also working in the same industry. He can also add his observations as well as Muriel. So this is the introduction as well as the top level what I'm seeing overall. Thanks.
Thank you so much. I'm going to throw a bit of a curveball here and try to put things in context a bit. So back in the dark ages, we had 1G, which was analog, and then there was a big jump to 2G, which was digital. And then 3G was voice. You could see sort of big divisions between them, sort of like different dinosaur eras. You could see it. And then when we went to LTE, it was a different modulation, different handoff. But 5G, to my mind, I know that there are differences between 5G and LTE or 4G, but it seems more subtle in some ways very big, in some ways more subtle. Do you think as we go on and on, the differences from that point of view will be smaller, larger? Will there be like huge revolutions? What do you all think?
I think it sort of depends, if I can just follow up on what you just said, Katie. The difference of those early Gs that you mentioned was in essence perceivable by the user, right? Like as a user, I can tell the difference between only being able to make a voice call versus watching videos on my phone, right? And so it's quite possible that the next large changes won't be as visible to the end user. I don't know, I'm putting that out there. That certainly things like self-healing, additional sensing, maybe with location precision, you might get a different kind of user experience, but a lot of it might be invisible. So I put that as a thesis for my colleagues to either endorse or shoot down.
Well, I think, from the one of the beauty of the Gs is that the certification process of a G is very rigorous, right? So it would be the ITU saying, look, these are the KPIs we need to hit. And then you can call that a 5G, 6G, 7G system. Now, typically these KPIs is what we have on the G-1 divided by 10 or multiplied by 10. So there's an order of magnitude change always, at least in that development. But there comes the interesting question, which I think Ubli has just been driving at is do we still perceive it, right? So does 1 gigabit per second download versus 10 gigabit per second download make a difference to me as a human? So I think Ubli is right. It will be asymptotically going to zero, but it will make a huge difference to all the other ecosystems we're starting to bind in, right? So Muriel has been referring to a machine age, right? There will be a lot of IoT coming in, and they will care very much about these 10x improvements. And but overall, I think we're seeing for our telco system to start now acting much more like a platform. So before we acted like a cable, right? So it was an invisible cable with loads of sexy features attached to this, but now we're starting to act like a platform, and platforms have that really annoying feature that you can't really say what's the kill app. Okay, if I asked you what's the kill app of the internet, you'd say, I don't know, right? So we have loads of kill apps. And I think that's exactly what we start to see, this transition from a very discrete set of things to very analog. I think it was either Ubli or Muriel has been saying this. So yeah, this is my 3 cents on the whole development.
Yeah, I agree very much with Misha that it is really a transition to a platform. And I think that part of that is also that we're seeing an increasing heterogeneity of the physical layer, right? And that was one of the things that you had mentioned, Katie, is, it's pretty clear to us at the physical layer or, the MAC and so on, how things were changing from one generation to another. Sometimes there were some strange starts, like I'm thinking WiMAX and LTE, but like you kind of saw where this was going. Here we're really seeing a proliferation, right? Millimeter waves already been mentioned, but you're having things at usual 2.5 gigahertz, at 3.5 gigahertz. People going at 600 megahertz, where we hadn't been hanging out for a while, and now to 28 gigahertz. And increasingly, I mean, one of the things that struck me with the 5G standard is that it mentions how to work with non-standard technologies, which I think you can read for as being Wi-Fi. So now you have this huge richness, this array of different technologies, which clearly are not going to be available equally at all places. And at the same time, you're trying to give very low latency and really high reliability. So this is now, as Misha said, it's a platform. Now, how do you make it work as a platform without getting lost in the fragility that Ugly mentioned before? And how do you do that, to go back to what Ravi pointed out, at scale, right? Not just beautifully, exquisitely designed in one little corner of, like Times Square in New York, but really in a way which can be applicable to rural areas, developing areas, highly developed, dense areas. How do you do that? So I think that this idea of having a service-oriented platform, and also to going beyond rates. We talked about 1 gigabit per second, 10 gigabit per second. A lot of the time, I believe right now, we're using rate as a substitute for actually providing low delay. That's to say, one way of getting low delay is just to do the same thing I was doing before and just do it faster, just bump up the Nyquist rate. But is that always necessary? Maybe it's not that I really needed that much rate. Really what I needed was much tighter delivery guarantees. Again, going back to this idea of being a platform for crucial services, which need to have a real measure of delay, of timeliness to them.
So I would like to chime with Misha as well as Muriel. Over here from 4G to 5G, the basic differences, if you can see, mainly hardware software decoupling, a lot of cloud assets, and at the top of it, all related to management service-based or service-oriented use cases. So I think the major difference happened from 4G to 5G is a connectivity-based business to a service-based business. You moved. And when you consider that fat pipe as a platform for everything and anything, that adds a lot of value here. Because when we moved from the standard connectivity, a base station, to a radio unit plus an edge infrastructure at the tower, and that infrastructure is not only allowing you to have the RAN pieces, but maybe the user plane pieces from the core, some part of NWDAF for smart analysis for the core, and a lot related to artificial intelligence sitting there and doing a lot of inferences. So those things are also changing the DNA of 5G and later on going to 6G, because earlier the major thing was a very tightly coupled set of, you can say, specifications you need to meet in terms of latency, in terms of throughput, in terms of other things. But now your requirements are much different, because there are three different kind of requirements. One is your MMTC, another is your LLC, another ADMBB. So all three of them, they have a very different set of requirements. And that's how the whole slicing is injected. Why slicing injected? Because then you can customize your services for the SBA you are going to build. And I think in 1 to 2 years, you can see that SBA will be totally dominating to the enterprise services, not necessarily to the connectivity services, but enterprise services they do. And in coming 5 to 6 years, your revenue base, 80% is coming from a non-connectivity based services. So definitely, when you add those kind of things, ultimately it is going to change the DNA. And how the DNA is changing is a cloud asset is getting more and more importance. Artificial intelligence consumption, not only cross-stack optimization, which has never happened. As Urbasi said, that like hardware co-development in terms of algorithms and all. So those kind of things now slowly started taking shape. JCAS, joint communications and sensing, those kind of things started taking shape. I know that it is not yet scaled up, but with time you can see a lot of it going to come, and it's going to disrupt. At present, like it is so surprising that earlier there was a complaint that, oh, connectivity is not really prepared for next generation services. Now I can see the amount of progress connectivity has done with time. I feel personally that services and applications are not really ready to consume the smartness what connectivity is bringing as on date. I haven't heard like from a single service provider, especially applications, how they are prepared to hook in with NWDAP, how they'll be utilizing the RAN smartness or their cognitiveness, how they'll be
Ravi, don't you
the
think
best set of resources.
once you start really proliferating AI and ML, it will eat up your pipe very quickly? Like I'm actually not worried about that, right? I worry about that, and this is something that Muriel raised in our pre-panel discussions, the notion of how much of our traffic is going to be devoted to AI and how much of our traffic is actually going to be devoted to signaling and communicating. So let me throw this out because it's shown up in the chat, and it's near and dear to my personal heart as well as my professional heart, which is increased privacy and security might be something that I would be willing to pay for, right? As a user of this wireless network. The other thing I would like, which goes back to something I think that you said, Ravi, which has nothing to do with connectivity, is a brain-to-machine interface with my phone. Right? I'd like to be able just to telegraphically, if you will, have my phone do things for me without having to touch it, especially as an older person for whom texting is not that easy.
Okay, so we have a lot of questions in the chat that are just awesome. And let's start at the very beginning. And end user willingness to pay for 5G has declined. The market utility of the generation 2 MNOs is dropping. What do you all think about that?
Yeah, these are the facts because hardly I can see that the ARPU has changed. It's going to change and coming 2 years down the line for connectivity. And that's where hundreds of billions of dollars is spent by Verizons of the world or AT&Ts of the world and everyone worldwide, all the tier ones, tier twos, that needs to be recovered. And I have a lot of hope related to enterprise solutions, MNO-driven private enterprise solutions, private 5G enterprise solutions, multiples, intercoordination with NTN, or you can say non-terrestrial networks. Agri-tech is coming up, and smart e-health is going to take shape. So multiple other, and of course, metaverse, we are going to enter into metaverse. So a lot of revenue is going to come from those where the subscribers are ready to pay for a specific service, not a bunch of services. And I'm sure that the trend is developing.
Do you think
So
that users
if I
are
can
paying
just
for
come in from the vendor
connectivity
point
or
of
the
view,
service? Sorry,
oh,
Misha, go ahead.
yeah. So just to latch onto Ravi's point. So, I have a lot of these discussions, telco where we're today, and, we clearly have moved into a commodity phase, and everybody seems to be scared of this. I think commodity is great. The telco industry isn't poor by any means. You look at the balance sheets, the EBITDA of most of the telcos and the vendors around the world is extremely healthy. And the reason is because, being in a market where you don't have to prove the utility of your product is quite powerful, right? So there are other advantages to this. And as a startup founder of quite a few startups, I can tell you the companies where I didn't have to prove the utility of my product, where actually it is a commodity product, do best. Okay, so therefore it is not bad to be in this age. On the other hand, I really don't think that the CSPs of this world, so the operators, will have a massive increase of the top line opportunities. I think Ravi's right that the enterprise market will be interesting. As a telco community, we have always tried to make the bottom line savings possible, so have 5G be much more efficient than 4G if you normalize it per bit, etc. So we'll do this, but at the same time, I really don't think we should panic as a telco ecosystem. We are $1 trillion market with healthy EBITDA. So and let's build exciting stuff on top, right? Let's let the metaverse flourish on our amazing technology. Full stop.
But are service providers going to be providing these applications versus the connectivity? I mean, I think there's a disconnect there in the sense that it's a different set of organizations that I might be, for example, buying my privacy application from, which will be independent from the person or the entity offering me connectivity. So unless these service providers want to start getting involved in some of these key services, there is a challenge. I mean, it's
They
still
want, they all want. The problem is not that they don't want. I worked for France Telecom for many years, so I know they want, but we just don't know how to do it, right? So here you go.
But I guess this is what I'm saying. I'm not sure I would buy that service from France Telecom, but I might buy it from, Privacy R Us. I don't know. Muriel, you were going to say something.
Yeah, I mean, I think there is actually a commonality in all of these because yes, there is a commodity, there is this, in effect, expectation now from people that they will have, fairly decent, ubiquitous service, and that they may be less willing to pay for that service as is. However, as we know, people are willing to pay for the applications that go on top. And I wanted to go back to what Ravi mentioned before about slicing, right? Because now, if you can provide well-tailored slices, where, on top of this commodity, I agree with Michelle, it's not a bad thing to be in the commodity market, the worst markets to be in, for us as a profession, it's good to be in something that everybody wants. It's basically an infrastructure, people expect to have it. But in order to do, in effect, a price discrimination, you then provide people different versions. And I think that tunability, I think 5G is trying to get to that tunability. It's a first step towards it. It's not entirely there. I mean, there is the slicing, but really, for instance, going back to the delay issue I mentioned before, can you really go right now to 5G and say, look, I'm not really interested in a particularly highly responsive setting right now. I just want data. I'm just, and the application will negotiate that versus I really need something that's extremely responsive, not necessarily a lot more data, not necessarily going to get 10 gigabits per second to take the example we mentioned before, but I really need to have very tight delay guarantees, and of course, the inverse of the expectations, not the expectation of the inverse, right? We're all engineers, we know that. So, if Jensen's inequality was almost an equality, the mutual information would be zero, and we would know we can transmit no information. So, there is a big difference between rate and delay. Okay, just to start with the first with the first level of differentiation. So I think that differentiating in the context of slicing can actually provide really, really interesting venues for us as engineers, and I think for the entire for the entire industry. And obviously enterprise is, that has been mentioned already by Nisha and Ravi. That's of course, probably the best place to start. But I think everybody will benefit from this sort of, slicing negotiated by directly with the application.
And I would like to quickly add one more thing. Oversee asked that who will do it, like especially in metaverse, whether the operators will do it. I don't think so. I feel that metaverse, I'm seeing a mixed bag oversee. I can tell you like what I'm seeing at present. So I'm seeing two approaches. One is in partnership with the hyperscalers. And the second one is going with your own first and bring your metaverse framework from the operator side. But because out of that 6 layers or 7 layers of metaverse, at least 2 to 3 layers of it will be provided by operators no matter what, right? Our device ecosystems or a high compute fabric or high capacity compute fabric and high capacity edge with the FPGAs and all. So no matter what they are going to. So the partnership is a must. And there are multiple metaverses, and operators can only provide some of the very low-hanging fruits. Ultimately, it's a vast ecosystems around it who will fill the gap somewhere.
Mhm.
This
I
is
agree
how
with
I'm
that.
seeing.
No, I completely agree with you, Ravi. And when I said commodity, I meant it's on the data rate, right? So that's what we are. But then there are the sweet extra things which you both, Muriel, and you have alluded to, is for instance latency. And it would be great if we could have, let's say, a whatever metaverse slice, whatever you want to call that, right? And then offer that, against what a payment to consumers. There are quite a few markets, specifically the high liquidity markets, where net neutrality actually prevents us to do that in a very simple form. It's all doable in one way or another. And you, Ravi, will know that there are always ways to get around things here and there. But I think we need just a global view on how to deal with that net neutrality. Enterprise is fine, but the really big market, your 80, 90, 99% market is consumer market. And for a company like us, it is important to have a global vision, because this is when we can scale and therefore also offer, the products, of course, cheaper to you guys in the end, and therefore offer a much cheaper network. So therefore, the net neutrality rules, I think, need to be discussed. And I'm not taking any side here. I just feel we need to revisit that whole topic at some point.
Okay, so there was a point in the chat about, I think from Misha, about discussing the AI layer in Ubli's deck.
Yeah, I find it very interesting, Ubli, and I think you would get support from, I don't want to take a company stance here. I'm speaking personally, having spoken to quite a few people within Ericsson, and I think it would be interesting to explore. Really interesting, but it requires something very, very big, and that is to standardize AI. And I've been surfacing that notion for quite a while in various communities, not least very recently here in Silicon Valley. And not everybody is happy about it, let's say, because
You don't
there are
have to
pockets.
standardize all of the AI. You kind of, all what you need to standardize are like the sockets, if you will, right? The connectors on either end of the stack. And
Yeah,
and
that's
I'd
what
like
I
to
mean.
think
So
that is
clearly, like we
more,
do it in telecoms, right? So you need
exactly,
the input, and maybe we can discuss it later. Maybe just one side or none of the sides, just the
exactly.
APIs essentially. Yeah, but it's that big step which is needed. I can tell you, there's not a lot of positive voices on that, but I like it. I like it, and I think that's the way forward for federated learning. Federated AI is a huge opportunity. So I'm with you on that.
That's great.
Do you all want to add anything about the AI, Ravi and Muriel?
Yeah, I actually wanted to relate a little bit to this again, to the issue of net neutrality that
Yes.
Nisha brought up. And actually, there was also a note about net neutrality in the chat. I forget who brought it up. Because the idea with AI and and intelligent use of the network is not so much that you're not being neutral, is that you're allowing people to figure out what's important to them, right? And I think there's a difference between not being neutral in terms of always favoring certain aspects versus tailoring, right? Everybody wants something that's tailored, and it's not necessarily that having something that's tailored is not fair. I think that one of the possibilities that the AI layer, to borrow what from the previous discussion provides, is a way of doing that tailoring, right? You could give me in effect the same fraction of the resources, and I could try to push it more towards having more rate, towards having more delay. It's not necessarily unfair. It's not necessarily not neutral. And so I think that instead of going to a one size fits all or fits none, is, let's say, a Pareto optimum performance. That is to say, given my utility, I'm no worse off because, Misha got exactly what he wanted, and maybe I got exactly what I wanted. And it doesn't look the same, but that's what we needed at this point for the applications we were running currently. I think that moving towards a much more tailored and intelligent approach, which really will require, by the way, going back to the heterogeneity I was speaking about before, will really require us to be able to use all of the available, at that point, instantly available resources. I mean, I want to say one of the things also about net neutrality. What does it mean to have net neutrality when you're working over multiple different networks at the same time? If I'm connected to a satellite and I'm connected to the Wi-Fi here in the lounge, neutrality over what? Somebody else is only connected to the Wi-Fi. Somebody is connected only to the 4G network. It really, the question is really, can I get what I wanted in the cheapest way possible that allows as much space as possible for my fellow users who all are interested in just getting the best experience possible to have it their way.
So Muriel, I'm sure that you are looking for something federated where like your requirement is the prime, and then based on the most optimal way you can get the connectivity. I'm sure that the industry is working, and we are probably, I'll say, 5 to 6 years away from there. I think if you see from 4G to 5G, even coexistence of Wi-Fi plus LTE or the 5G, there is a huge improvement happen, right? So like I'm also the part of WBA, they are doing a great work, especially in this area. I'm very positive that in coming 2 to 3 years, because now you can see that Wi-Fi 7 is almost launched. Like I can see that Broadcom had just sampled 7 of their different chipsets for Wi-Fi 7. Wi-Fi 7 is very close to what advanced 5G or maybe 6G will converge, and coexistence of it. So I'm sure that the industry is working for it, but how fast it can be a reality is hard to say because of the business cases and use cases. I'm also seeing that Google Fi is also doing a lot of roaming and all those patchwork for some time. But I think with technology and with some of the other business cases and use cases, it may help to accommodate those kind of things. In terms of AI layer, standardization is a must. In terms of RAN, I can see that ORAN has done a great work at least define the different ML interfaces as well as the analytics and others. They have defined the 3 different engines. They have already defined, they're working on it, but at least they are doing it. Transport and core side, still like the work is going relatively slower, but I'm sure that with NWDAF and others, like things is coming fast. I'm hopeful that probably, and I have also seen in the last 1.5 years, the whole SMO work, like service management or orchestration work, is really grown exponentially, and our artificial intelligence layer is an integral part of it, a huge piece of it. I think what I would like to see that that AI piece is exiting or at least coming out of SMO and going further south, going to the telco edge or metro edge at least, and not only managing the infra but also working to the payload, complete context aware, or working to the control side of it, or what Urvashi was talking about, JCAS, or kind of joint communications and sensing capabilities, so that it is not only dynamically managing the network infrastructure resources, along with that also slicing dynamically to the next level. I think all those things probably in a 5-year time frame, hopefully 5 to 7. I'm hopeful that a lot, because I have a lot of hope from the SMO side, because there's a lot of investment going on SMO side. So you can see a lot of innovations as well as compliances coming with time.
So I'm going to play, I don't know if it's devil's advocate. I mean, generally I'm an optimist about, the technology that we can bring to bear, but I think 5 years is being overly optimistic. So let me explain my my thinking here. So if you want to use AI ML at the physical layer, that's probably the least, that's the place where a mistake is likely to cause the amount of trouble, right? But as you move up, you're going to affect more and more parts of the network, large parts of the network simultaneously. And one thing we are seeing is AI and ML is still very fragile, right? And it requires a profound amount of training data in order for you to be truly convinced that everything is working. And so to me, when we all start driving self-driving cars or engage in, self-driving cars, that will probably align with the moment where we are willing to have AI play a larger role in a network, right? Because if you have one glitch, the amount of revenue lost is going to be profound. So I think we have to go cautiously, optimistically, but cautiously, and recognize there are only going to be certain subsystems within our wireless network where the cost of an error is going to be modest. That will be the first places where we use AI and ML. And as it permeates more, we're going to have to be much more careful, which is why, and this gets back to actually something that has been running through the chat, which is, a lot of what this AI and ML is going to be running on, the training data, is going to be user-specific data, something that I generate through my pattern, my behavior, my mobility, and maintaining the privacy of that, as well as assessing the ownership of that data. I would like to think that I am my mobility pattern, right? But in a way, I'm going to have to relinquish this in order for the AI to behave properly. And researchers are finding now that federated learning is not as private or secure as has been implied. It's a gap that needs to be filled. In fact, I see people nodding. All of us said originally, oh, just exchanging local models, that means, none of your data is going to get out. Well, that's clearly not true, right? As long as there is some statistical relationship of your data within the models that are being passed up, inference about you can be made. So this, I think, is going to be one of our challenges. How do we create the training sets, the data sets that maintain privacy and security for the individuals, and have them be large enough so that we can have faith that the AI is learning the right complex input-output relationship? And we are nowhere close to that, right? We can't even get dogs and cats straight, with minor poisoning of the data, right? So anyways, I just think that we're not there yet. I'm optimistic that we're going to get there, It's going to be a slow road. It's going to be a little bumpy. There's going to be some major crisis that's going to occur, the equivalent of a power outage in some region, but it's going to be a connectivity outage due to some AI error. And then we're going to step backwards, very afraid, and then we're going to have to revisit, how we move forward. This is my realism as the academic in the ivory tower.
I think that maybe the first step towards that full optimization is already just having more flexibility.
So I'm going to get back to this idea of standards that was brought up earlier. Will we have standards in the future? As somebody who's been to a standards meeting and didn't enjoy it, but I know some people really do enjoy it, and I understand the importance of it. Will we have standards in the future? And if we do, will they be like they are now, or will they have a totally different slant?
I can take the first go on this. Oh, Muriel, you go. You seem to have a little outage on your announcement in the airport. Yeah.
No, you go ahead.
All right. Well, I've spent quite a bit of time thinking about this. So, I mean, a stance is clear. The standardization process is a consensus process, right? So, therefore, if it was to be replaced one day by machines or augmented by machines, that this would need to be brought in. That consensus bringing would need to be brought in, and we have great mechanisms of doing that. Blockchain, distributed apps, and all that. So there's great ways. Actually, we have the tools of doing that. But in the end, it comes down to a copyright thing. And, I think a judge in Australia recently ruled that stuff which has been written or designed by AI cannot pass even the simple patenting laws. And patenting is simple compared to copywriting, right? So it's a completely different league, the copywriting game in general. And therefore, I think we need to change a few legal constructs which we carry on for hundreds of years, really. So patent laws are, quite dated, to say the least, and they do a lot of good things. So I'm not saying they're doing bad things, but maybe we can adapt them to a more modern time and see what could AI do to accelerate the process. Have AI maybe help us build consensus quicker. You can think of 3GPP meetings, which normally take maybe on one study item for people to converge within 4 months, 5 months, 6 months. This could be done in milliseconds, right? Depends on how much compute power you throw at that. It can happen very quickly. And then when you have a trace of provenance on that, and you're able to actually implement that and make that happen, and maybe even write this into a more verbal text, which could be interpreted by humans, which I think is very important, then we're on a winning streak. And then we're in a winning streak. And if that happens, then I think the landscape of standards will change significantly. And I do know that Etsy is exploring that today. So it's not like we're starting to ask this question now. It has been in the pipeline of thinking of various very progressive standards bodies already. So yeah, I see an interesting future ahead. And I don't mean to get rid of engineers, human engineers. They will always be needed, but maybe we can accelerate things. That's my view. Thank you.
So let me ask the following to the entire team. So I worked standards in the 90s in between my master's and my PhD. And so something that is interesting and unique about AI and machine learning is that a major contribution does not necessarily have to come from a large entity, right? But classically, wireless standards, again, it's been a long time since I've worked in this space, typically seems to be a negotiation and consensus building activity across relatively large entities, right? Think of the major companies. And so how do you think we can include some of these smaller organizations, small firms who may be able to create a major step forward in terms of AI and ML and how it should be standardized into the discussion? Because I think that democratization is going to be necessary if we want to have the best solution possible.
Yeah. And I think this gets back to the point of the flexibility, Lubli, and you had talked before about a socket, it basically an API. And I think maybe the question a little bit is, what do you need to standardize, right? There's a lot of standardized technologies which maybe could be left to be more flexible, to have more choices in it, as long as they play nicely as long as they provide the right API, the right socket, right? I mean, I'm thinking, you spoke, Ubli, about, co-design. One of the things, of course, I work in is looking at universal decoders that don't need to have a particular code in mind at the time that you make the chip. So basically, maybe all I really need to do is standardize, other aspects, and, the code can be chosen, but, by mutual agreement for the, in order to satisfy whatever service is most, most well suited to the application at that time. So I think that maybe thinking on the standards and really reflecting about what exactly it is that they need to standardize and what maybe can be left open. This gets back to your point of maybe that would allow some other entities to enter more easily just because they need to simply abide by the right API. And there are other areas of technology where that's more common, right? That you're basically just standardizing the API. I'm wondering whether a move of the standards more towards a minimalist approach to standardization might actually allow all of these aspects.
Agree with you, Muriel. I think we need to decouple some of the things which is common to play with, and the rest of the area open for all. Especially take a case, now 5G is all about cloud assets, orchestration, artificial intelligence, a lot of areas, they doesn't not necessarily fall under SDOs. But yes, in terms of defining the technology, defining the communications, they fall under SDO. And of course, as Urvashi was talking about, that definitely big corporates and all, they have their, surely they have interest because they're spending billions of dollars in research, right? So somewhere they have to protect their right. So that I'm not seeing anything wrong in that. But yes, from 4G to 5G, if you see, and 5G going to 6G, I'm sure the influence of whether it's a 3GPP or HC and all is going to change. But as Misa rightly said, that the policy makers in every country, they need to think in a very different way. Things are changed. The whole fabric is changed from 4G to 5G. I think the policy needs to be aligned as per that, so that I think some of the areas, and I think I also understand your pain, Muriel, especially going something which is so disruptive and so useful, you're going over the air or over the top, rather being that one is the integral part of my stack. How to make it possible? I think about like everybody, if you go from 5G to 6G, I think what exactly the industry is doing, they're working a lot on FEC, right? So if there are some standard interfaces developed and some of the things, if you can put it to the standard FPGA or the DPU framework and integrate it rather than going over the top, things will be much efficient and useful. A less energy consumption, faster user experience and all. So I'm sure that at present we are kind of at a phase where lots of things are changing, policies are not defined, but we can't ignore SDOs because they had a great contribution in 4G going to 5G. And I'm sure like they're also expanding their scope of work. Like if I see ORAN individually, starting from the front hall, going to the cloud native asset, going to the SMO, they have tried to, and now going to the artificial intelligence and defining their smart radios. They're trying to cover as much as you can from the operator's perspective, from the vendor's perspective. They try to, and I'm sure that 3GPP is also going to. But the challenge with 3GPP is that IPR needs to hit before you are going for the discussion. So it makes you slow by nature. And like the way AI is disrupting the whole thing, I think it'll be really very interesting to talk very specific how exactly the policymakers, as Misa said, that they need to realign and the things what you can do in 6 months, it will be done in fraction of a second or maybe in minutes. How exactly the policymakers are seeing it, and how you are but the challenge is how you will be protecting your IPRs. I think that is a question. How you will be protecting your huge investment, especially related to the lower layers or your productizations.
So Ravi, I think you raised this has been raised by a number of people. And Misha, you haven't been in the US that long, but you're going to see that the ability for technologists to influence policy in the United States or play a role in it is likely to be very different from the experience that you had in the UK. And this is something that gives me pause, that there is a lot of technology illiteracy amongst those who are designing these policies. We have a few limited positions where technologists can play a role, but given that, the size of the use and the markets that are involved here, it's very limited. And I don't know if that's something, since we have an international set of experiences here that we can talk about. The other point I wanted to raise, going back to this AI socket notion, is that this is a double-edged sword, right? Right now, we think of telephony, wireless communications, and connectivity as largely being governed by trusted bodies interacting with other trusted bodies. The moment we make it easier for anyone else to play, we make it easier for anyone else to play, which includes non-trusted users or those with intention for malice, right? And so, and I go back to my personal wants and desires. I will pay for improved privacy and security with respect to my wireless communications and interfaces. But we're not in a position where I can actually pay for that product, right, to ride on top of my wireless service. And I think it's something that we need to be devoting a lot more time and energy to. So two different things if people want to react or respond.
I'm conscious we're kind of short of time. So the one thing I think we really should discuss is the privacy notion. So I didn't quite hear, Ubli, if that came out of your comment, but I'd love to talk about this one. It was raised by somebody in the chat.
No, I agree wholeheartedly. I think I think it's something that's neat. Again, going back to my stack picture, even though I'm not necessarily a proponent of all things modular, we need to start thinking about privacy at every layer. We're going to need a multi-pronged approach. And I think this is only going to become a bigger challenge in the future.
I had a few years back, I introduced that notion of privacy by engineering design. I mean, you will have heard privacy by design. But I think this is a term which is quite misunderstood. So, because in the end of the day, privacy is really a T's and C's at the moment. So if you want to use Google Maps, you have to agree to the terms and conditions. If you want to use Facebook, you have to agree. And we have trusted them, right? But we don't know what's truly happening. We have seen sometimes what is happening. It's always, but it does happen. So we have solved security at layers 1 and 2 and 3 and at application layers. So what I've been advocating for quite a few years is to also solve privacy at layers 1, 2, and 3 and application layer. And I think we need more brain power on this. We need to understand how to do it. I think we're starting to get very clear idea about this. But the same way as we bake security natively into our engineering stack, we should do the same with the privacy. So this is something I would want to see with the emergence of 6G, joint sensing and comms. Sounds like a privacy nightmare to me. I'd love to see that in the metaverse, which sounds like a privacy nightmare to me. So we need standards around this, tech solutions. We need to have engineers at this, and not necessarily, computer scientists at layer 7 or at application layer. So that's what I would love to see.
So Misa, I think nowadays SASE is getting very popular.
I was actually going to say SASE.
And then SSE
what
both.
we need is PASE.
Exactly. So SASE and SSE, you can see that recently. I think all the mid-sized companies are selling in billions by the big boys. So you can see SASE is very popular because they are hitting in 3 places, like your subscription, application, as well as the infrastructure, all 3 of them. But yes, I think the way you are talked about it, Misa, which is very particular, like how about policy securing you when I'm going to Google, I'm searching it, and how my searches will never be touched by anybody. who will be touching and how it will be touched. There are some rules, but it is not as customized for you. I think that is, and I'm sure that even SASE being triggered in place, then also I'm not expecting any change for something what you're talking about, Misha.
But as Misha pointed out, there are other aspects which are peculiar to wireless, right? Because SASE is always over the top, right? Versus again, now people are sensing because as you mentioned, Ravi, you're going to have, simultaneous sensing and communications. I'm somehow giving away things differently in the wireless setting. And I don't know, if people have seen, wireless oriented SASE, which, would be interesting, but you could imagine being a very rich area of investigation, right? Because we are, providing a lot more information, not just explicitly, but implicitly, just by the use of the technology. I mean, I think one of the things we talked about trust, right, earlier, and the entities and trusting the entities. And I think that, one of the things that heterogeneity of, this variety of technologies that we're sort of all joining together in helping us, sort of orchestrating and helping us get the services we want. One of the things that's great is, you may not trust any of them, but, you can have trusted services over untrusted entities, as long as you do it correctly, as long as you do it in a thoughtful fashion. If I'm only interfacing to a single entity, sure, maybe I really need to trust that entity. But if I'm myself still in control of my destiny by how I orchestrate over these various entities, of, splitting up, not just sharding, but coding and so on, then it actually opens up some really interesting new possibilities, I think.
You can also think about having measures of trust, right? So you are originally an untrusted entity that I need to interact with. And through prolonged interaction, I can decide to elevate your trust metric or devalue it as a function of our interactions. So
I would like to challenge that. So
okay.
I'm not a big fan of these levels of trust. It's a bit like saying we're going to have levels of security. You don't see a packet to be secured or non-secured. A non-secured packet is a no-go in our telco stack, full stop. So, it should be really, we should have a design which allows us to really operate at privacy level 100, okay? As we operate at privacy level security level 100. So therefore, this notion of trust, in my role, it's something which has been cooked up at application layer. It has nothing to do with our engineering layer. So that's what I'm trying to convey. We need to just get really hands-on, and I think also a bit stricter in what we want to achieve with our privacy by engineering design.
But that implies that you have to not trust any entity that you interact with,
Yeah,
which means I don't trust my own infrastructure. I don't trust your infrastructure. I trust no nodes. Maybe I don't even trust the recipient of my packets, if you will. And it can be done, but it's going to be expensive.
I was going to say, isn't there a financial issue here? I mean, right now, Facebook and other companies make money off your information. And that's why it doesn't cost anything. But if you want privacy, you're going to have to pay.
I agree with you. But I also think that if you pose a problem well, we as a community are smart enough to find a solution. So I'm hopeful.
I don't think we have to operate in absolute zero trust. I'm going to put that out there. And there's going to be some pieces of your information that you're comfortable leaking and others that you're not. What is challenging, of course, is understanding that if you leak A, what does that tell someone about B, right? And some that it is complicated to, to compute. So it's good that we don't agree on everything. That would be terrible.
I think we should set the bar very high, because I think we just have not set the bar high enough, really. So we have set the bar very high on a lot of things, but then not on things related to privacy. And that's all what I'm saying. So you can call it whatever you want. You can call it, whatever KPI you want to measure the degree of privacy that you want, but it has to be extremely high. Okay, so that's what I would like.
It has to be something you're willing to pay for. And if I just throw in like generational divides, I see a big distinction in terms of, say, my teenagers versus myself.
Yeah,
right?
but I think it's also policy, right? In terms of pay, we've been talking about paying, SASE is something which you choose to have as a service, and you pay for that service. But I wanted to bring up something you pointed out before, about differences in policy in geographic areas. For instance, in the US, there isn't GDPR. And that's just an example of a difference in policy which does affect how data is managed, and what
And in the US, we have state by
leakage.
state differences as well, right? I mean, in
Indeed,
California, we
indeed,
do
yeah.
have a version. So
But that does again, I think all of that speaks to the ability to have a very flexible platform that can be, that can adapt to different needs. Because, whether it's because people are paying for it, whether it's because the local laws require it, whether it's because, there's a modification that occurs at the level of the application by the application itself, as it's maybe managing more data that's more confidential. It speaks to the fact that having something more tunable and flexible is probably really useful, rather than having a one size fits all.
going to need AI to figure out our trust.
That would be ironic, right? But I think we all agree that more work is needed, and I think that we seem to be agreeing that we, as engineers, we can do more to help with the privacy in future networks. So
there was a question in the chat from Simon Fletcher about needing humanities skills as well as technical skills in this. What do you all think about that, in sort of future standards and driving these things?
Oh yeah.
Well, I think digital equity is a huge issue, and we've seen this worldwide. And again, going back to policy in the United States, we're not treating activity like a utility, which all individuals are entitled to, and that's something that we need to figure out. And please forgive me, my corporate colleagues that are here. I think unless corporations are forced somehow to do this, or there's some government action, I don't see it happening in the US without an external pressure, because of course the financials don't work out for providers to make sure that every single human is connected, and yet that is something that we need to be doing. I don't know if this is the humanities that Simon was referring to, but it's something that we need to figure out how to do.
He refers to a meta model, so I think it gets around some of the copyright issues which are lingering, and then the IPR issues. So you would use AI, Simon, correct me if I'm wrong, use AI essentially to augment, let's say, our human understanding of what we could do, and then humans would translate that. And then maybe in the standards we have two sections. One is written for the models, and one is written for the machinery, right? And in fact, this is happening today. So if you look at the NWDAF standard, which Ravi had been alluding to in 3GPP, it has two sections. One is the very verbose thing written clearly by humans, and one which is the more formal one, which could be machine verified and implemented very quickly. So I think this is an exciting interim future, and Simon seems to confirm that's what he meant. Yeah, I think that would be nice to see.
Yeah, I think there's also, going back to the applications. I mean, in the end, the applications those are truly user-centric, right? And so understanding what are the quality of experience factors so that we can design services, so we can design a network that is actually responding to those and not to, metrics which are such as throughput, which, is a very reasonable metric. Nobody would say it's a goofy metric, but, it's maybe a little bit too limited. So I think that having it also more nuanced understanding relatively to what the needs of the users are is important. And again, when you're talking about equity, Uli, the equity is really, I think, more responding to needs. Not everybody may have the same needs or wants, but can you respond to them and provide it to them in a reasonable fashion?
Okay, so we're getting ready to wrap up time. And do you all have some final thoughts before we say goodbye?
Goodbye.
I have to say this was a lot of fun. I think that having these conversations is is probably one of the few things that really allows this more two-dimensional medium to sort of prove its worth. But I think that I was surprised by how much convergence there is philosophically, and often in terms of how we think that technology will or should move forward. I was very struck by that. And not because we were trying to avoid controversial topics or difficult conversations, just because I think that there is some real commonality here of that there's some intellectual synthesis that's occurring, and it was nice to see. It was very, very, very pleasant. Thank you.
Thank you, Katie, for organizing all of this, and Abby for providing support. I also want to say that I've been trying to track the chat as we were all talking, and really great points were raised in the chat in terms of the questions. And I'm sorry if we could not get to all of them, but it was
one
a
of
great
the things
experience.
we can do is when we post this on our website, we can also post the chat. Is everybody in the chat okay with that?
I would answer that.
Okay.
They could answer it in the chat.
We can answer in the
In the
chat.
chat.
Yay.
Yes.
Okay.
So,
Self-referentially.
Okay. Well,
Agreement by omission or something, right? If we don't hear from you, we assume you are comfortable with it.
that's right. There's
Right.
something in Robert's Rules of Orders about that, but I can't remember it. Ravi, do you have anything you wanted to say?
Yeah, so I think before we close, definitely I would like to thank Katie and all of you. It's proud to be the part of this discussion. And I think this was a very different kind of discussion. Like I'm very actively participating to a lot of these discussions in the industry, but this was very different, like something in open spirit, thinking something which is really painful and going openly and talking about it. Probably I feel that the area where I feel more work is needed is how the academia and industry can work together at a much larger scale than we are now. I think that is the area, and I can tell you that all SEF as well as ORAN and all, you can see that within few months you see that a lot of initiatives are coming where we will, as SDOs, we will interact more and more, and here as well as invite the academia to be the part of their policy making or the work. So I'm very positive how academia can add a lot of value to what we are going to have in coming 7 years down the line. And wish you all the best, Urvashi and Muriel, because me and Misha, we belong to the industry, but definitely would like to invite and like to see more, and Katie, you too, to be the part of the journey, being the part of the scaled version of 5G Advanced and 6G.
Yeah.
I think it's a great comment, Ravi, and I think we would like to, but I think we're all challenged by the academic incentive structure, if you will, and interaction again. And I'm sorry to keep raining on the United States, but I think we are challenging the U.S. by the inability to come up with good agreements between companies and academics, except on one-by-one cases, which definitely occur. And we all have great experiences of working with industry, but there's a constant revisiting of, IPR constantly, which can be painful in many cases. And so I would really love to see all of us to be able to come forward and create new models that benefit both sides, right? Because as academics, we need to be interacting with industry. It's where we get new problems, where we understand what your challenges are, and help us create our vision for the future. So it would be great if this was easier. And of course, it would be on our side. We also have the challenges of our university legal system, right? Where it's the two legal systems battling each other, whereas the industry engineers and the academic engineers who have understanding and agreement, but the parents, if you will, are not letting us play together. So
Ubli and I think every 2 months on a panel discussing that. So Ravi, I think the ecosystem is trying to make it work. But anyway, to conclude from my end, I think, Kay, it was great. It's great to see everybody again. It's a great stimulating discussion. I think we all agree we're excited about 5G. We're excited about 5G++. We're excited about 6G, but we need to answer some very hard questions to get this right. And that was the view of this panel, that we looked at these hard questions. So thank you so much.
Well, thank you all. I appreciate it. This video has been recorded and it'll be posted up on YouTube and our website within the week, we hope, the editing gods willing. And we will see you later. Thank you all for coming, and we appreciate it very much.
Thank you so
Thank
much.
you.
Thanks a
you
lot,
all.
everyone.
Take
Bye.
care. Bye-bye.